Hey friends, welcome back. We're studying for exam 2 for solids. We've got a composite beam problem. Half the beam is made out of wood, right? You give us the E for wood, modular elasticity, and E, the bottom is made of steel. So find the maximum stress in the bonded beam shown in both the steel and in the wood. So how do you do this? Looks like just a regular old stress. Got bending. This is just MC over I, right? Yes, that's true. But the MC over I equation is really set up for one material at a time. So in order to do this, I'm going to have to convert this beam from two materials into one material. Okay? If you remember how to do that, we use the old N trick, don't we? Okay, which is E1 divided by E2, right? Take one material's modular elasticity divided by the other. Now, I like to have the big one on top always, so that way that when I divide that, I get a number bigger than 1, okay? So I'm going to do this. N equals 200 divided by 12. They're both gigapascals, so that's going to equal something. Let's go on. Tangent, 200 divided by 12. 16.67. Okay, so that's my N factor. Okay, so what I've got to do now is I can either turn the steel into wood or the wood into steel. I've got to convert this into one material. I think I'll convert the wood rather, into steel, right? So if I had this much wood, and I was going to replace it with steel, do you think it would take less steel or more steel than that to replace it? Less, right? So the new would look something like this. Now what you can't do, okay, what you can't do in these problems is you cannot change the overall height. Okay, so this was 160 plus 30, it was 190. Guess what it's got to be now still? This has still got to be 190. This has got to be 160 up here, okay? That cannot change. The only thing that changed is the width. It went from 180 to some new value, and now the whole thing is steel. How do I figure out what that new value is? Well, it's just this divided by that, right? That's like our strength ratio there, okay? So I'm going to take 180, divided by answer equals 10.8, okay? So this is now 10.8 mm's. So I got a new beam, okay? It's all one material now. It's all steel. It's not really, but we're going to convert it back when we get to the end of the problem. But now I can do this on it, right? I can do this, okay? I can do my regular old thing on it. Now, in order to do any of that, now M is the only thing I know right now. I know that this guy is given 4 kilonewton meters. That's one thing I know. So how do I find C? What is C? C is the distance from the neutral axis to the outside of the part. So from here to here, or from here to there. Well, I don't even know where the neutral axis is. That sounds like a perfect job for Centroid man, okay? So I'm going to divide this into two shapes, shape 1, shape 2, X. Let's see, what do I need? I need Y, don't I? I need Y. Here's 0. This is my datum down here at the bottom. Okay, so I need to know where, what I'm looking for is where's that, right? Which is Y. So I got Y and A and YA. And here we go. So for shape 1, Y bar is, there he is right there. Right there's shape 2. 15. And the area is 30 times 180, right? This was 180. Okay, and so 30 times 180 is 5,400. And then times 15 is 81,000. Okay, then number 2, where is that one? There it is. It's half of 160, that's 80 but I got to go from the datum. So it's 30 plus another 80. Okay, so it's 110. And then the area is 10.8 times 160. 10.8 times 160. 1728 times 110 is 190,080. 190,080. Okay, plus 81,000 is 271,080. And this is what? 82167. 7128. So y bar is 271,080 divided by 7128, which is divided by 7128 equals 38.03. All right, so that's how far it is from the bottom to there. This distance here, 38.03. And I could subtract that off of like 190 minus answer equals 151.97. So this up here, 151.97 is here. Okay? So far so good. We haven't really done too much solids. This is statics, isn't it? We found where the neutral axis is. While we're here, could we go ahead and calculate I? Okay? The answer is yes. Okay, we're trying to calculate Ixx, which is 1/12 base times height. We'll do piece number 1 first, right? The base is 180. The height is 30 plus 80 squared. The area, I got it, it's 5,400. And the distance that goes in here, the D, is what? 38.03 minus 15. So 38.03 minus 15 equals 2303. I knew that. Okay, and then plus, here comes piece number 2, 1/12, the base, 10.8. Oh, there's a cube right there, isn't there? Times BH cubed. H for piece number 2 is 160 cubed plus the area, 1728, times D squared. And that is 151.97 minus 80, right? So 151.97 minus 80 equals 71.97. Okay, let's calculate that up. Let's do this line and then we'll do that line so we don't make a mistake here. 180 times 30 cubed is divided by 12 equals plus 5,400 times 23.03 squared equals. Okay, this one is 3269056.9. Okay, so 3 million there. Here we go one more time. 10.8 times 160 cubed equals divided by 12 equals plus 1728 times 71.97 squared equals 1,263,688.8. Okay, and then plus 3,269,056.0, no, just 0.9 equals. Okay, so I is 159,059,45.5. 15 million, what? Millimeters to the fourth, okay? All right, let's write that up here so we can get us some room, okay? So IXX is equal to 15,905,945.5 mm to the fourth, okay. So let's erase this and give us some room here. Y'all understand where we are so far? Again, that was statics. We covered that in statics way back, okay? So did we do that right? I hope so. All right, now we're ready to go. We got to calculate MC over I. Now what we're going to do, let's call this point A, and we'll call this up here point B, okay? We're going to find the sigma for both those points. Now point A is going to be steel, isn't it? So sigma at point A is equal to M. 4 kilonewton, oh, let's just do this. Let's do it. 4,000 Newton meters, but let's get rid of that meter, okay, which is 1,000 mm's, okay, burp, burp, times C, okay, so for A, down on the bottom, what is C? C is the distance from here to the outside of the part. It's 38.03. Okay, that's mm's divided by I, which is that giant number, 15,905,945.5 mm's to the fourth. Okay, and then while we're here, sigma at point B up there on the top, right to that point, same moment, 4,000 times 1,000 times, different C this time though, 151.97. So it's neutral axis to the outside of the part, right? Divided by same I, 15,905,945.5 equals, okay. So let's see what we got here. So that's 4,000 times 1,000 times 38.03 equals, divided by 15,905,945.5 equals. Now what is all this going to be? This is newtons over millimeters squared. That's megapascals. So I got 9.56 megapascals. Now that is sigma for point A, which is the steel, right? Because remember, point A, this was the steel, okay? So this point B up here on the top is going to be for the other material. So let's see what that guy is. 4,000 times 1,000 times 151.97 equals, divided by 15,905,945.5 equals 38.22. 38.22 megapascals. Now, is that number correct? Is that right? The answer is no, because that number, remember, I converted it into steel. Now I've got to take that. Now I don't have to unconvert this one. This one is steel. It was always steel, right? But this one I'm going to have to unconvert, okay? Because we converted it from wood to steel. Now I got to go backwards. I got to go back to this, okay? So this is too big. This is way too big. The wood's not going to have as much stress as the steel does. So take this number here and divide it by our N again and unconvert it, 16.67, okay? So divided by 16.67 equals 2.29 megapascals for sigma wood. And there's your wood, there's your steel. If we do these, don't forget that last step. You converted it, you got to unconvert it, okay? All right. Hope this helps. Make 100 on the test. Send me a note. Let me know how good you did, okay? Let's go.